Very good morning to you all. The presentation topic for today is wind farm power quality analysis and ECAP. We'll be discussing today about the scope of wind energy in India, introduction to power quality, and the simulation tool which can be used for power quality analysis. Well, to begin with, if we speak about India, today India ranks fourth with respect to the largest installed wind power capacity in the world. The world leaders in this wind power sector are China, United States of America, and Germany. If we speak about Maharashtra ranks third with respect to the state-wise wind energy production in India. Apart from Maharashtra, Tamil Nadu and Gujarat are two other states which are abundant in wind energy sector. This is a pie chart which shows the world installed wind capacity. From the pie chart, it's pretty obvious that countries like United States of America, Germany and China are the leading wind energy countries with leading wind energy production. India is having an installed capacity of almost 25,188 megawatt. This digit must have definitely improved. This gives an indication that there is a lot of scope in the wind energy sector for power system engineers in India. What is the problem what are the difficulties which an engineer has to face when it comes to wind energy sector? That can be termed as problem identification. The dynamic nature of wind energy is responsible for many challenges to harness it and to make as per the required standards. Few challenges which can be enlisted are power quality. Now it is pretty clear that power system engineers are very much focused and concerned about the quality of power which is delivered. Power quality can also be termed as the quality of voltage. A sinusoidal waveform indicating the voltage is an indication of good power quality. Power quality is any problem which is manifested in voltage, current, frequency which can lead to maloperation of consumer equipments. Apart from that, power quality is also of prime importance as it decides the life and efficient working of consumer equipments. Again comes the question of reliability and stability when it comes to wind generators also. There are certain grid codes which are to be followed with respect to the frequency variation, the voltage variation, etc. Economic feasibility is again one more question. Thus, this field remains most enriched for research and further analysis for a more efficient and optimized way of energy control. It is very important to identify the problem in this sector. Now, power quality issues. There are various issues related to power quality. Some can be termed as short-term variation, some can be termed as long-term variation. To further categorize it, we can term it as voltage sag, voltage swell, and many more. These power quality issues are also related to the variable nature of wind speed, which ultimately results in variation in output. Also, wind generators are sensitive to faults. A low voltage can also isolate the generator from the mainstream, and again this wind turbine generator should be equipped with LVRT characteristics. What do you mean by LVRT characteristics? That is low voltage right through capabilities. Harmonics are a major concern, a major issue in wind sector. Now what are harmonics? Harmonics are integer multiples of the fundamental frequency. A distorted waveform gives us an indication that the system is having harmonics. Harmonics can be further categorized as third order harmonics, fifth order harmonics, which depends which order of harmonics is having a different impact on power system equipments. Reactive power in the system is also a major concern when it comes to the wind energy sector. There are various types of generators which can be used in the wind energy sector. To begin with, the squirrel cage induction generator, which is most simple in construction, rugged in construction, which was used on a large scale in the earlier days. Doubly fed induction generator, which is of great importance and which is used on a wide scale these days, which can also be termed as DFIC, and a permanent magnet synchronous generator. What are grid requirements? A wind turbine should be connected to the grid for a specific time period during fault condition. It should not be isolated. The wind farm should maintain a certain power factor limit as determined. Reactive power compensation should be of prime importance, and certain measures like capacitor design and implementation, static war compensators, fact devices, fact devices should be taken on priority. Further, the frequency limits as decided are to be maintained. The system should operate in the desired permissible voltage limits depending upon the level of voltage, which we will be discussing in the further slides. The harmonics associated with the power quality are of prime concern, and desired steps should be taken, like a design of harmonic filter, minimum use of electronic devices. There are various measures which can be used to reduce the harmonic content in the system. Again, a proper protection scheme in terms of under and over voltage protection should also be employed. Further, frequency protection unit should also be employed to maintain the frequency in the permissible limits. Now, what are the grid codes with respect to the voltage withstand for various wind farms? If you see the table, the voltage levels are being listed here. The percentage variations are being listed, which says that the voltage variation and permissible limit is allowed. Further, what is the maximum voltage variation and the minimum voltage variation is also discussed. If we speak about a 132 kilovolt system, the permissible voltage variation is plus 10% and minus 9%. Further, it can rise only, the permissible limit is maximum of 145 kV and minimum of 120 kV. These grid codes, when it comes to voltage requirement, are to be maintained. Now we'll also discuss about the harmonic limits. If we again speak about a 132 kV system, the permissible THD, total harmonic distortion, is 3% and should not rise above 3%. These are certain standards which are being laid down. To discuss, to study the harmonic limits in detail, you can also refer IEEE standard 519. So we'll take one generator at a time. We'll discuss the squirrel cage induction generator. As discussed earlier, squirrel cage induction generator can be used in the wind energy sector. Further, this is the topology of a basic principle of a squirrel cage induction generator. You can see that it's being employed with a gearbox. The gearbox can have various ratios. For example, 1:98, which can be used to maintain a steady output. A squirrel cage induction generator is used, and further a converter is used because generation may be in AC, transmission losses are to be reduced, and thus DC system has to be employed. So this is a general topology which can be used in any types of generator. This is a general topology in a squirrel cage induction generator. Further, what are the features of a squirrel cage induction generator? To begin with, it's simple and ultimate rugged in construction. It is having minimum maintenance, it is having lower cost, and it has good power factor and higher efficiency. The drawback definitely lies in the reactive power. Further, we'll discuss the simulation tool and the opportunities which the simulation tool gives you for various analysis.